Good day, everyone, and welcome to yet another exciting episode of AI Climbing with Sheikh. And thanks for joining and supporting and learning together. And this is perhaps an extension of the last video, which actually went quite good, got lot of questions and responses around the local AI PDF assistant, right? And where we really started was with a use case, right? I don't want to bore you with lot of models and maths and science around it. But the way I started it, we all know in our local systems, in enterprise, maybe in your own laptops, you have a lot of data. It's very typical 500 TB. I am actually now going to 1 petabyte, and then how to sort, index, and query different documents by context. That's really is the use case. If you have not watched that video, perhaps you need to start, and you can see the link. There are two channels, AI Climbing with Sheikh, where you are in. There is another Unpacking Mysterious Things, and it's really good and mysterious stuff there. Go click watch it, mainly around the cloud privacy and lot of work we are doing with the local communities in Australia, schools, police departments, few other exciting stuff. So yep, without boring with you with some of those stuff, let's start today's journey. And it will be a mix between a sort of theoretical and algorithmic world and a demo and application all together. Because look, research is very important in this space, and to make sure that you are applying the right logics to solve, and that's pretty much where I sits in my job as well. And today topic is how you can enhance the performance of your local models with data, which is a trusted data here. And I will be actually going on some of the different approaches. And if you can see over here, the whole idea is we started our LLMs, Chat GPT of the world with more like a centralized repository or data store from where we can actually query different data. And then we combine lot of context, and like DeepSeek, even the Chat GPT with their new models, which they call the task-oriented models. And you can definitely see that we are moving towards that direction. And as you can see, if we compare the accuracy of the humans to recall their instinct and brains, 60% perhaps, and then you can see with LLMs we were low, but then with the architecture, so where we are going, if you can see over here, right? Ultimately, a distributed architecture with an LLM teacher student architectures are a key where we are going. Again, if you want to learn the latest on this, do check this paper. I will be touching a bit on this as well. But where my today demo will be focusing on how you can actually start with the more like a teacher student model. And if you can see over here, the initial thought in my last demo was just a very static one. There is a student, right? And it has some intelligence, but mainly it gets is from its teacher, right? Which can be a llama, DeepSeek, whatsoever model. And what learning by teaching means is a concept of a feedback loop where a student initially start learns from teacher, and based on his intelligence over time it will not only enhance but giving the feedback, giving a chance both to the teacher and student to learn from each other. That's perhaps how our brains and our human society works. But look, this is architecture which I will be implementing today, and let me go out of the um, PPT world to a more like a research world, and I will be really giving you a snapshot of the research into this space. So the first paper I really want you to see is the LLM intelligence that can really they can learn through the teaching mechanism, right? And if you see, it's just few months old, and perhaps I should do a like of zoom in, and as you can see, right, there is a lot of theoretical aspect, but the whole idea is learning by teaching type of mechanism, which I am going to implement today. And there is different methods and approaches. They actually start by building three architectures and comparing that. I will be going primarily on L1, and again somewhere between L1 and L2, using some of the recent advancements with the lab architectures, which I will be covering in next episode. But where I want to just focus is the key point over here, right? It's around the different feedback mechanisms which you are seeing over here, and that I will not be doing the retraining. Obviously, I am retraining locally, so I can't do it. But one slide where perhaps I really want to show you a bit of here, it's around the different comparison results between the different models, and how they are actually gonna compare to each other. And yeah, it should be around, but maybe it is on another paper. Again, if we go to the other paper, this is not very old. You can see over here from our very favorite MIT, and they are doing a lot of work around this. Again, they are sharing the idea of how we can add context and learn in this distributed way, and they put lot of the scoring. So you know this for ROG, which is the baseline of LLM. ROG is the main metric, and then traditional for the ML, different learning mechanism. And they put different models and different approaches, but then the purpose, I think it's a good idea to go through some of the research papers, and how actually to go from the research world into a business world. But where I actually want to just show you is the game of accuracy, and the whole idea is how we can build a model which perhaps gives you better context and understanding than the model or human brain itself, right? Just go check it. If not, you can go to our mentor and dear friend Vlad, who actually shares a lot of stuff. And just check, and don't forget to follow him. I really want to thanks. It's a good one, and here he really try to explain this paper, right? Like different architectures and results and how they are impacting. But look, this is more about how I will map it into a real AI system, and not explaining you the nuts and bolts of research. But that's pretty much all I need to share in terms of the background and how I am going to do it, right? And now let us try to go through the code itself, because I always believe if you can't see something right running and dancing, it's very hard to understand this world, which is our AI world. And the whole idea is building secure and trusted systems. And yeah, let me try to now start all of these algorithms, how I actually trying to map it into the system or application. So again, I will be using a Streamless app, again loading of the APIs, and I seen that Hugging Face did some changes, and I needed to revamp some of the code. And so maybe the first part is more about that piece which I needed to add, because previously I was just using the Hugging Face login and give the token from the my local environment one time, but it looks that you need to really load it in your program. And again, this is a Streamlit app, and the whole idea is I will show you that M1, the first architecture with teacher student model. I will be showing you a power from the vector databases, FAISS, FICE, and number of models. One as teacher, one as student, Olama and DeepSeek, and yep, that's pretty much all. And we will see a working chatbot, and from where we can start. I think it's important that we see that in this code we will be using LangChain for the AI pipelines, FICE for the fast document search. Again, think it like a vector search, and different models, and Hugging Face embeddings more about the tokenizations, and Streamlit for my app. And if we go to our code now, let me just try to show you, right? Obviously, as you can see that Streamlit app, I pass some file here. You can start with anything, right? And actually, you can make it a more wildcard as well. Again, you can see over here, it is loading that, then doing the splitting or chunking. If you can see over here, you the we call the Hugging Face models, and then docs, as you know, as Hugging Face traverse and split the models, everything is basically a doc. And then we will doing the vector search and splitting over here, and again building a LLM. Remember, you need to run the sort of model locally. I installed Olama with the DeepSeek 1.5 billion. And then again, this is how my app expects to work, right? So there is the context and question and an answer. You will see as I will apply different architectures, how this is gonna work. And you can see over here, I do a prompt, and then there is a lang chain, right, where I am linking my prompt and context to the model. And you can ask a question. So look, this one you have seen, right, going to the local document and search. But then if you don't find, he actually goes to the teacher model and get answer. So this is a very basic mechanism, right? If then else sort of scenario. And it's not the right in terms of the feedback. But then I really want to go into different steps, and I hope you can see the value, right? We will apply the lab architecture in next demo, and hopefully that will explain how the two will sit dynamically. And yeah, let's try to see over here that we will use. We are using the files to store and retrieve the document chunks, and student model to retrieve the data from the local documents, and the teacher models, which is the Olama based DeepSeek R1. And now, obviously, you will be interested to know that will it work or not. And I always make sure right things are there. By the way, you can always download and check and try. In my GitHub, and you can always find me in my some projects in Saad Sheikh. And yep, let me try to. Check it works. Hopefully, it's real time and it will work. And yep, let us try to check. All right, so this is not bad. Let's try to see that how it's gonna work. And I hope, if you recall in my last demo, it was just going through the document and answering it. So consider it more like an HR admin, big data files, and you don't want to read. But then in this case, you remember in the last demo when I asked Australia, I did not get go answer because there was no fallback. Can you explain? Oh no, all right. Can you share about Tech Life in Melbourne? All right, let's see. So, what I implemented is a student model which is intelligent enough with local RAG, but now I gave a file which is the Red Hat AI platforms, and you can expect that my document has zero information about it. So look, it is going and going, and after it will fill, it will fall back and it will go to the teacher. And if you can see over here that it actually goes right, and it actually first tried to go into the red hat and see if it has any relation, right? But now you can see, right, that even it go to different links and this and that, but it did not find anything, and then it will fall back to the model. And if you can see over here, it is used into the Melbourne, and then it is going into the model. And why you are not finding intelligent one? Because perhaps the DeepSeek and Llama 1.5 billion also don't know anything about it. So that's pretty much how you will implement and make a more intelligent system, and make it more contextual for you. So don't forget to read these research papers, because it's very important that because code sometimes is very simple, especially with the Gen AI tools of the world, but then your task is to map the intelligence to the code world. So that's pretty much all for today. Thank you for joining and supporting. If you are liking it, don't forget to share with your colleagues, like, subscribe, and let's continue our journey together. Thank you for today.